Dr. Bones here with Skelly Skeleton. A little more chemistry here. Skelly's got his safety glasses on. Hey, Dr. Bones got the safety glasses on, ready to go. Okay, so we've got a couple of light bulbs here. In this case, I've got an electrode, a couple of electrodes with an open circuit. I'm going to close the circuit by inserting the electrodes into a liquid. Now, just because I put this in a liquid doesn't mean that it's going to be a good conductor and the light bulb will light. Right, I've got a power source here. For example, some people think that water is a wonderful conductor, and you have to watch out for water when it's got salt in it for sure. And I wouldn't want to step in water while I'm playing with electrical devices, but in this case, it's not going to be the greatest conductor for this type of setup. Let's put a little water in here. Let's see if we can get this light bulb to light up. Hopefully, I don't know if I didn't rinse these containers out, but let's find out. Pretty hard to see if you zoom in there. Usually with the light bulbs like this, you have to turn out the lights, but in this case, you're not going to see anything with just the water. So we need an electrolyte. We need something that's going to dissolve in the water, but ionize in the water, create ions. Well, I've got some sugar. Sugar is not going to do the job, and I want to show you that it's a molecular solid. It's not going to ionize. So just because it's a solid and it dissolves in water doesn't mean it's going to work. I just want to prove it to you. It's always good to prove science to yourself. Stir it up. Might taste really great, but it's probably, unless I've contaminated it with something else, not going to light up this device. And sure enough, it doesn't light up. So we need something that's going to form ions. Well, there are weak electrolytes, there are strong electrolytes. I've got some vinegar here. Vinegar is a weak electrolyte. It's an acid, and its acid proton is available, but it's going to be weakly available. Not by the weak, but meaning it's going to fall off very weakly, not going to be much H plus in the solution. So let's try it out. Got another light bulb here. Put it in. May give me a little bit of a light, but that's okay. It's a weak electrolyte. Let's swirl it around, swirl it around. Very, very, very weak. I can barely see it. Okay. Actually, there, I'll lower it here. Very, very weak. All right. Just to prove something to you, I've got some salt here. This is called the sodium chloride. Various salts, but this one's sodium chloride. Just want to put a little pinch in there just to see if this electrode setup is working properly. And there you see that it's very weak. There's a very, very weak light. Of course, I can see it easily, but probably not with the camera too well. Let me just see if I can put a backdrop here. If we were to put this blue here, you can see just a very, very weak light. Getting a little stronger there, you can see it, but very weak, so not much sodium chloride in solution. Let's put in much more sodium chloride. First thing I need to do is get rid of this water solution. I want to replenish it, make sure that I'm not contaminating things. Put in a little bit more water. This was with the sugar water. Rinse it out again. It's a fun experiment, but you've got to make sure you're diligent about washing things out. And we will put this one back. Rinse out the electrodes a little bit. Put in some table salt, in this case sodium chloride. Don't need a lot. Watch, you'll see what happens here. Put in a little bit here. 1, 2, 3, a little bit. And there you go. Nice bright light. Let me put the blue backdrop here so you can see, yeah, very bright. Okay, so there you go. Take it away, put it back. So a very bright light. Sodium chloride, very good electrolyte. So it's sodium plus, Cl minus. So that certainly works. But other substances will work. Let's put that back in. See there? Flashes on, flashes off. There you go. So sodium chloride, good electrolyte. We said that the acetic acid was not a good electrolyte. Vinegar smells like vinegar. Good for salads, but And you can see there we had with a little bit of sodium chloride. In this case, I'm going to put some hydrochloric acid, so no sodium chloride, but HCl. Still will operate just like the sodium chloride. Instead of Na plus and Cl minus, we're going to get H plus and Cl minus. So let's put that over here. Rinse this out. Make sure that, just to prove it, that it doesn't work with the, let's put some water in here. So this is regular water, or you can get distilled water. So here you see it, no light. Just wanted to make sure that I'm showing you that we're not contaminating this with other things. Let's move this to the side here. So we're operating on this one here. Now here comes the HCl. So that was water. Here's the HCl, so it'll be H plus, Cl minus. Should be a nice bright light. And wow, that's even better than the sodium chloride. So very, very good dissociation. The ability to dissociate, form an electrolyte solution with the HCl. Wow, that's even brighter than the sodium chloride. So that's even better. About 100% dissociation. That's really neat. So let's take it out of the light, into the light, out of the light. So good electrolyte is HCl. What about a antacid tablet? We've heard about acids. What about bases? Here we've got some antacid tablets. I'm going to, again, rinse this stuff out. Make sure you got everything. We'll go to this one since we had a stronger acid there. Let's get this weak acid combination out of there. Rinse it out. We're going to crush the antacid tablets. Antacid. If you've got an acid, then you probably want to get rid of it with a base. So we neutralize the acid with a base. Some of these antacids have aluminum hydroxide. Most of them probably calcium hydroxide. Some type of magnesium hydroxide. A weakly dissociating hydroxide, not sodium hydroxide. That's deadly. So you want the hydroxide, but you don't want it in high concentration. So we take 2 spoons, we put the antacid tablet, right, here's the tablet, here's the tablet, we put it between the 2 spoons, right, again with the tablet. So we don't throw the tablet directly in, it will take forever to dissolve, so we crush the tablet. I'm going to put it in, there's the powder, right, so the powder goes into the jar, or in this case glass, right. So we've got the powder. And I've got some water, stir it around, it'll be some kind of a milky white solution or suspension we call it. But will it really be a good electrolyte? Let's find out. I don't think so, because you're not going to get a lot of hydroxide. Like I said, sodium hydroxide is a good electrolyte. Of course we got too much salt in here. I'm going to have to rinse this out again. Some more water for rinsing. Always rinse these things out before you test them, so that you know you're not being, you don't have contamination from something else. So let's just rinse this off. There you go. So that's some regular water or distilled water. All right, so here's the magnesium hydroxide. I put this in the magnesium hydroxide. Oh, not very much at all. So not really all that great, only because we don't get a lot of breaking up of this compound. We don't get ionization, at least not very much. So it's good when it's in your stomach neutralizing the acid, but we don't want it to be too strong, so it really causes trouble for your intestinal and your digestive system. Let's just show you that if this is hydroxide and I have a sodium hydroxide over here, to show you that the sodium hydroxide will dissociate much more readily than the magnesium or aluminum hydroxides. So just to prove that, let's take a tablet, rinse out this container, and put in the sodium hydroxide, and we'll get that light to light up, because the sodium hydroxide is a much better electrolyte than the magnesium hydroxide. So don't use this to neutralize your stomach acid, believe me. Not a good idea. In fact, This would be good if you had a clog of your drain, but I wouldn't recommend you going to the chemistry lab and just trying that out. Get some liquid plumber or something like that. All right, so here we go, and into the solution. The only problem here is we've got to get that sodium hydroxide to dissolve. It's a little pellet right now, but as you can see, the light is slowly getting brighter and brighter and brighter. So the only real way to do this is to make sure that the sodium hydroxide pellet is dissolved, and it takes a while. But once you get it going, and there you go. So a much better electrolyte. So again, on, off, on. So the sodium hydroxide, yes. The magnesium hydroxide, no. This one, yes. Antacid tablets, use them. This one, no. Please do not use this as an antacid tablet. So there you have it. A little bit of electrolyte chemistry with the Dr. Bones Show, and my friend Skelly had his safety goggles on. Always wear your safety goggles. I should have been wearing my safety glasses here. I took them off earlier because it's getting a little humid, but so Skelly, you should have reminded me. Well, I was ready to go. I forgot, Dr. Bones. See you around. Okay, I'll see you around. Take care. The Dr. Bones Show. Have a nice day. Bye for now.